Today we're going to talk about arithmetic sequences. Before we begin to explain what arithmetic sequences are, we are going to first just start to look at some patterns and sequences in general. If you take a look at letter A, you will notice that this pattern is adding 6 each time. So the pattern means it is increasing by 6. If you take a look at your next example, I'm subtracting 3, subtracting 3, subtracting 3. So this pattern is going down by 3. Our next example, you will see that from one term to the next, we are adding 10. On letter D, you will see that we are going down each time by 2, so our pattern is that we are subtracting 2. If you look at letter E, you will see here we are adding 3, but here we are adding 6. Because that pattern isn't consistent, that's not the pattern we are looking for. Instead, we're going to try and find a new pattern. So from 3 to 6, 6 to 12, you can also see that we are timesing by 2. So that is our pattern there. So this pattern is also a little bit different. You can see that we're not multiplying consistently by anything, but if you look at this pattern here, I add 3, then 5, then 7, then 9, and you can see that there's kind of a consistent pattern that way. The other way you could look at it is 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. The next one we would get would either be to add 11 or to go 6 times 6. And then you have this pattern. This pattern you will see is also a little bit different. This pattern is interesting. This is called the Fibonacci sequence. You can find this in nature. It's quite interesting if you ever look for it. But if you add 1 and 1, you get 2. If you add 1 and 2, you get 3. 2 and 3 get 5, 3 and 5 get 8, 5 and 8 get 13, and so forth. So the pattern here is you add the 2 previous terms. And then if you take a look at all of these patterns, you will quickly see that everyone's just a little bit different. So today we're going to talk about one specific kind of arithmetic sequences, and that is the kind where you are adding and subtracting consistently amongst terms. So if you take a look down below, an arithmetic sequence is when the difference between each pair of consecutive terms is the same. This difference is called a common difference, and each term is found by adding or subtracting the common difference from the previous term. So an arithmetic sequence is when these are all the same and you are either adding or subtracting consistently. So the first thing we're going to do is we're actually going to look at whether or not something is an arithmetic sequence. So if you take a look at this little picture here, what you're going to do is if you are given a graph with points, you are going to compare your y values. Your x values will always go up or down consistently by a number, but you have to compare the y values. So from 0 to 1, you add 1. From 1 to 4, you add 3. And from 4 to 9, you add 5. Because this is not consistent, this is not an arithmetic sequence. Here, you will notice you'll look at your y's. From 21 to 18, you subtract 3. 18 to 15, you subtract 3. And 15 to 12, you subtract 3. Because those are consistent, this is an arithmetic sequence. The next thing you will kind of look at with these graphs is if you were to connect these dots, you will see that that line is curved, not an arithmetic sequence. And that line is straight, which is an arithmetic sequence. Let's look at our next example. It says write the next 3 terms of the arithmetic sequence. So all you have to do is find the pattern and then continue the pattern on. So to go from 1 to 8, you add 7. 8 to 15, you add 7. And 15 to 22, you add 7. If you cannot figure that out in your head, the way to get that common difference is to take the second term and subtract the first term, and that will tell you what you are adding by. So then to get the next term, you are just going to take 22 and add 7, get 29, and then you're going to add 7 to that and get 36, and those are my next 2 terms. So if you can't do some of this in your head, you can also do it on your calculator. So my next one, if you can see it in your head, you are subtracting 6 consistently. If you could not see that right away, you just take your second term and you subtract your first term, and that's how you get your common difference. To then get my next two terms, I'm just going to go 2 minus 6, get negative 4, and then go negative 4 minus 6 and get negative 10. And those are my next two terms. For my last example, you can see that you are going from one to the other by adding 9. If you cannot see that, you just take your second term, 21, and subtract your first term, 12. And then all I do is continue the pattern. So I add 39 and 9 and get 48. And then add 9 onto that and I get 57. So I found the next two terms. You could find the next 3 or 5 or 8 or as many as you wanted by following that same pattern. The next part we are going to do is we are going to write an equation for an arithmetic sequence. This is an equation that you will have to memorize. And I like to write it slightly different than this. I like to write it where the D is actually written in front of the parentheses. So these two things are the exact same thing, but I just think this is easier for when you have to distribute. So if you look at this formula, this a sub 1 is always your first term. The D is always your difference. And then the a sub n and the n just represent those values. So a sub n is what the nth term is. So this is your term number, the n is your term number, and the a sub n is what that term number is. So say I wanted the 10th term. Say the 10th term was 32. If I plugged in 10 here, this would be 32. So this is your term number and this is what that term number value is. Okay, let's try number 9 first and we'll come back to number 8. So the first thing you have to do is you must find a pattern. If you will notice between each term, you are subtracting 5. Once you find that pattern, what we're going to do is we are going to follow along and fill this information in. A sub n stays a sub n. Your first term is whatever your first term is listed. And your difference is whatever your value was that you were going up or down by. Once you get that general form for your arithmetic sequence, you then just have to simplify it. So I'm going to distribute the negative 5, and get negative 5n plus 5. And then I'm going to put my n piece first. And then what I'm going to do, because these are on the same side, I'm just going to combine those like terms and get 48. And that is your equation for the nth term of an arithmetic sequence. Now the other instructions also said to find a sub 25. So if you are trying to find a sub 25, what that means is you are trying to find your 25th term of this sequence. So all you have to do is plug in 25 to your equation, and that gives you what your 25th term is going to be. Let's try another example. Say this one's a little bit harder and you can't quite figure out the common difference. All you do is you take the second term, negative 6.6, minus the first term, negative 5.4. So my difference here is going to be a negative 1.2. Once I find that, I can then plug in my values into my formula. My first term is negative 5.4 plus my difference, and in this case it's a negative, so I made that a minus, and now I simplify. I distribute here, negative 1.2n. That times negative 1 is a positive 1.2. I then keep my negative 1.2n, and I'm going to combine those two like terms. If you cannot do that in your head, you get out your calculator, punch them out, and that turns into negative 4.2. Once I do that, I need to then find my 25th term. So I go negative 1.2 times 25 minus 4.2, and I get negative 34.2. All right, my next example, number 10, I'm going to do the same thing. I find out that my difference now is I'm adding 4. So I take and I plug in my first term plus my difference times n minus 1. I'm then going to distribute the 4. I'm then going to rewrite it. So I'm going to put my n piece first. I'm then going to combine the 6 and the minus 4 and get a positive 2. And that is my equation. To then get my 25th term, I go back. I plug in 25 for my n. 4 times 25 plus 2, and I get 102. Let's try another example. In this case, you can see that you are adding 2. Remember, if you cannot find that difference, you go negative 9 minus a negative 11, and you get 2. So now, for a sub n equals, my first term is negative 11, my difference is 2, and I still have that n minus 1. So I keep the negative 11, I distribute the 2, I keep my 2n, and then I combine my like terms. Negative 11 minus 2 is negative 13. Once I do that, I go back and get my 25th term. So I go 2 times 25 minus 13, and I get 37. On our next example, we are going to look at the same thing. So in this case, I first quickly can see this by looking at the problem and saying, okay, I am adding 3 each time. So a sub n equals my first term, 34, plus 3 times n minus 1. I'm then going to distribute the 3 and get 3n minus 3. I'm then going to keep my 3n and combine my 2 like terms. 34 minus 3 is 31. Once I get that, I am then going to get my 25th term by plugging it in. So I just go 3 times 25 plus 31, and my solution will be 106. The last example is going to be this one. So some of you are like, I can see right away that I am subtracting 2/4, which really is the same as subtracting 1/2. If you can't see that, here's what you do. You take your second term, put it in parentheses, minus your first term, put it in parentheses, and then convert that to a fraction, and you have your common difference. So in this case, a sub n equals my first term, which is 9/4, plus or minus my difference, so minus 1/2 times n minus 1. So I have a sub n equals 9/4 minus 1/2 n plus 1/2. And then I can keep my negative 1/2 n, and I'm going to add those like terms. If you cannot add those like terms in your head, you can go parentheses 9/4 parentheses plus parentheses 1/2 parentheses, and you can either leave that as 2.75 or you can convert it to 11/4. To then get my 25th term, I go negative 1/2 in parentheses times 25 plus 11/4 in parentheses, and you can either leave that as negative 9.75 or you can convert that to negative 39/4. Either one is a correct answer. The last example we're going to do is a story problem. So if you take a look at this problem, it says in an auditorium, the first row of seats has 30 seats in it. So if you think about this first row, there's 30 seats. Each row behind the first row has 4 more seats in front of it. So then this would have 34, this would have 38, and so forth. So what you're actually looking at is a sequence. And your sequence has a first term of 30, and then the common difference is you are just adding 4. So we're going to again write an equation for it. My first term is 30. My difference is 4. So I'm going to distribute the 4, get 4n minus 4. I'm then going to keep the 4n and I'm going to combine my like terms. 30 minus 4 is 26. So there's my equation. However, they didn't ask for the equation. They asked for how many seats were in the 25th row. So what I'm actually finding is a sub 25. So I go 4 times 25 plus 26. In the 25th row, there are 126 seats. And that is your answer.